سلام عليكم بەڕێزان. گەڕام وڵاتم بۆ تاوەکردنی بابەتەکانی کیمیای پۆلی 12 لە سیستەمی ئینگلیزی لەگەڵم بن گەیشتینە چاپتەری دووەم. I think we have finished the three theories, the three definitions of the acids and bases, which are Arrhenius, the first one, the second one, Brownius-Lowry, and the third one, it was Lewis' definition, an American chemist. Okay. Hopefully you remember the definitions. Which one was the broadest one, the strongest one? Of course, Lewis. Lewis' definition is the strongest theory, the strongest definition for the acids and bases compared to the others, because we have specified even the atoms, if they are acid or base, the ions, the molecules, everything. Okay. Let's have some general note, including all the three theories. I mean, I will talk about some general important notes that are related to all the three theories. Okay, starting from the basis. Good, very good. Assume we have a strong base in H2O. First of all, strong base in H2O, as you know, strong base is an ionic compound. It dissociates in water, right? Let's have an example for this. Example, KOH. The dissociation reaction for KOH, water must be above the arrow. This is a solid state to form the ions, or to separate the ions, which are potassium and hydroxide anion, the aqueous. Let's identify KOH according to all the three theories. Be careful. قوتابیان خواهگتن لویبی. او زور گرینگه. یعنی لیستا اوی فیربا. سیرکا. If we have a strong base in water, اگر strong base من هبو لناو آوی, لناو watery. Strong base که ابیتا چی. First of all, according to Arrhenius' definition, there is water and it produces OH. So this is Arrhenius base. Without thinking, it will become an Arrhenius base. How about the Brownius-Lowry, the second theory, Brownius-Lowry? Okay, according to Brownius-Lowry, bases are proton acceptor. They attract proton. But here, no, there is no transferring of proton. So according to the Brownius-Lowry, KOH is not a base. And according to Lewis, later in chapter 7, you will know why we don't have any acid and base according to Lewis for the dissolution of strong bases in water. Look at this. Potassium here is +1 and still it's a +1 ion. Here, hydroxide -1. So none of the charges change it. That means there is no electron transformation. So we will say it's not a base according to Lewis. The point is, if we have a strong base in water, strong bases in water, they are just Arrhenius base. They are just what? Arrhenius base. Be careful. They are just what? Arrhenius base. Good. Let's talk about the weak base this time. Okay. Strong bases in water, the strong base compound will become an Arrhenius base only. Okay? يلا بعد دوباره دلم دانا كتيا. Strong base in water is just an Arrhenius base. It's not a Brownius-Lowry base and Lewis base. It's time for what? Weak base in water. Let's see. Weak bases, as you know, we have three weak bases. For now, I'll take one of them as an example, ammonia, NH3, plus by H2O to form, because it's a weak base, so the reversible arrow must be used. To form NH4 plus what? Plus OH. Very good. Start from the weak bases molecule. Good. According to Arrhenius, according to what? Arrhenius, there's water, it produced OH. So this is Arrhenius base. Very good. According to Brownius-Lowry, NH3 has been converted to NH4. NH3, it has been converted to NH4. How to convert NH3 into NH4? By accepting a proton. So this is a proton acceptor, a proton attractor. it will become a Bronsted Lowry base also. And hopefully you remember that golden note. I told you all the Bronsted Lowry bases are what? Lewis base also. Look at this. So it's a Lewis base. Mister, if you have a strong base in water, the strong base will become a base according to Arrhenius only. But weak base in water, it will become a base according to all the three theories. According to Arrhenius, it can produce OH in water. According to Bronsted-Lowry, it accepts proton from the water molecule. According to Lewis, it donates a pair of electrons. Good. How about the water molecule? According to Arrhenius, it's just a solvent. According to Bronsted-Lowry, water has been converted into OH, so it's a donor. This will be Bronsted-Lowry acid ion. How about the Lewis? According to Lewis, if there's a chance for water to become something, it's a base. Otherwise, it's nothing. So, أو بقويري لويسي دبيتا سبابي من أقل بيت ما بتمان أو water بقويري لويسي يعني أوتي دبيتا بيس يانش هيزنيا تكاتك دبيتا بيس أجر أسيد إلى تنيش بي بلام أجر بيز إلى تنيش هات أو نابيتا هيت. Look, the neighbor of water is a base itself. So it's impossible to have two bases beside of each other, okay? And it's impossible for water to become an acid. So according to Lewis, water is nothing here. I'll repeat this point again. أو بقولي لويس يسيبو يعني دبو base يعني دبو هيتشتك. تكاتش دبو base water أجر تنيشتكي تسيبه acid بقى. No matter if the acid is strong or weak. The point is, for water, in order to become a Lewis base, there must be an acid as a neighbor of it. Good. Okay, for the last time. Strong base in water, it's only an Arrhenius base, but weak base in water, it's a base according to all the three theories. Very good. And about the acids, we have nothing as a new thing, okay? So directly, I'll leave these questions. I have explained all of them previously, of course. Yeah, these are your homeworks, and this is a summary of all the three theories. Now, let's classify the acids. Classify the acids based on the number of protons that can be released, that can be donated. Look, acids are classified into two main categories. Monoprotic acids are those acids that can donate only one proton. Okay, acids with donating one proton is called monoprotic acid. And polyprotic more than one proton. Okay, it will become either diprotic or triprotic. Diprotic or triprotic. Diprotic acids like H2SO4, H2S, H2CO3. Okay, Mr. Diprotic. Di, it means two. Acids that can donate two hydrogen or with two ionizable hydrogen. Look at this. Two ionizable hydrogen. Mr. How about this? I think this one, which is H3PO3, contains three ionizable hydrogen. So is this a typo here? No. This is correct. It's a diprotic acid. Because among all the three protons here, only two of them are ionizable. I'll tell you later why. Don't worry. So this is a diprotic. This is what? H3PO3. It's a diprotic. سيرك باشتك تبلم. أمن علاقة ملوينية تو لو بابەتەی چۆن فکر دەکەوێیان ئەم بە شێوازە علمی لەگەڵ دەڕۆم بە گوێرەی کتابیش لەگەڵ دەڕۆم لە کتابی لا نادەم نەسەن دەقی حەسەب دەقی کتابی ئەوە دایپرۆتیکەوە علمیانیش دایپرۆتیکە لە ئینتەرنێت و لە چات گپتە جیپیتیە چیە لە هەرچ دەپرسی سەرچاوەی علمیە جامیعەیە کتابی پۆلی دوازەوە دایپرۆتیکە لێ لە خۆت تێک نەدەبرێەوە triprotic. This is a diprotic because only 2 protons are ionizable. Only 2 of them. Later, دواتر پێت دەڵێم لە بەرچی تەنها 2 پرۆتۆنی ionizable. Just چاوەڕێکە باش شەبابی من وەرێرە. Triprotic acids, according to the book, we have two triprotic acids for you. Okay, so these are mandatory for you to know them. H3PO3, which is a phosphoric acid, and boric acid, but this one, phosphorus acid. Good. I'll get back to this. Just wait. Monoprotic acid. What is a monoprotic acid? Monoprotic acid is an acid that can donate 1 proton. How many protons? 1 proton. Look. Monoprotic acids are acids that can donate only 1 proton. It means they have only 1 ionizable hydrogen. Good. Per one molecule, of course. Example, HCl, HNO3, CH3COOH. Mister, how about this? It has 4 hydrogens, but it's a monoprotic acid. Can you explain this for me? Yeah, of course. Stay with me, my dear. This is CH3. CH3, carbon has 3 hydrogens. Another carbon, COO, okay? OH. This is a structure formula for the acidic acid. You will know this in chapter 10. Okay? The only hydrogen, look at this. The only hydrogen that is ionizable is the one in which attached to the oxygen atom. My dear, try to take this note. If the acid is oxy acid, يعني اگر اسیدەکە ئۆکسجینی پێوە بوو تەنها ئەو هایدرۆجینانە دەبنە donatable اگر هاتو بە ئۆکسجینیەوە attach بوون. Okay? Only the hydrogens that are attached to the oxygen atom can be released. This is for what? For the oxy acids only. واتە دەڵێم سەر ئەگەر ئاسیدەکەمان ئۆکسجینی تێدا بوو بەس ئەو هایدرۆجینانە دەتواندرێ donate بکرێن کە بە ئۆکسجینیەوە attach بوونە. Acelera, are they attached to the oxygen atom? No. They are attached to the carbon atom by a strong covalent bond. So these are not donatable. They are not donatable hydrogens. The only hydrogen that can be donated is the one in which attached to the oxygen atom. Bash. Good. Look at this. All acids that contain, any acid that contain, this group is called carboxylic group. As I told you, you will know this in chapter 10. Any acid with this must be weak and organic. Any acid with a group of carboxylic must be what? Weak and what? Organic acid. Get. Example, this is benzoic acid, formic acid, acetic acid. Which of the following is a monoprotic? The term of mono, mister, it means 1 donatable proton. Look, monoprotic, it means the acid has only 1 hydrogen or 1 ionizable hydrogen. Which one is correct? Mister, a monoprotic acid is the one that has 1 ionizable hydrogen. Not 1 hydrogen. 1 ionizable hydrogen. Look at this. Okay, it has 1 ionizable hydrogen. This one, it's a monoprotic, but this one, however, it has 4 hydrogens, but it has only 1 ionizable hydrogen. So this is a monoprotic also. D is correct. Good? Nice. Look, acetic acid, CH3COOH. However, it has 4 hydrogen atoms, but it's a monoprotic acid. Why? Because only the oxygen, only the hydrogen that is attached to the oxygen atom can be donated. Very well. About the polyprotic acids, we have 2 types, as I said, diprotic and triprotic. Di, it means 2 protons can be donated. Triprotic, 3 protons can be donated. Be careful with this. Let's take their definitions. Diprotic acid, it can donate 2 protons. Example, H2SO4, H2CO3, and H3PO3, H3PO3. My dear, wallah, last year I've been asked by this too many times by too many different students in too many different schools. Mister, this is a diprotic or triprotic? This is a diprotic. Am I clear? Diprotic. Look at this. This is phosphorus. Okay? Look at me, my dear. How many hydrogens are attached to the oxygen atom? 2. Only, as I told you, for the oxy acids, only the hydrogens that are attached to the oxygen atom can be donated. So now how many hydrogens can be released? Only 2 of them, but this one, no. Good? Nice. Triprotic acids can donate 3 protons as follows. Good. It's time to know how to write the ionization for the polyprotic acids. Okay. Stay with me. Listen carefully. Try to grab a white page with a pencil. Write what I'm going to say. Practice. Try to have a practice with me right now. This is a good opportunity for you. Think about this. HCl. If I remove the hydrogen, it will become Cl negative 1. H2S. Oh, mister, it has 2 protons. How many protons? 2 protons. First of all, acids are molecular, so they ionize. Okay? If the acid is a monoprotic acid, it ionizes through one reaction, through one step. The ionization takes only one step. Okay? But if the acid is a diprotic, the ionization must carry out by 2 steps. 1 proton per any step. If the acid is a triprotic, the ionization takes 3 steps. 1 proton per any step. Now, since H2S, it has 2 protons, so we will remove the protons gradually, one by one. First, remove 1 proton, will become HS. Try to add negative charge by the same number of protons that has been removed. If 1 proton is removed, add negative 1. If 2 protons removed, add negative 2. Now, for the second step, remove this one. It will become S negative 2. Okay? This one, compared to the initial molecule, it has 2 protons less, so it needs negative 2. This one, compared to the initial one, it has 1 proton less, it needs negative 1. Another one. H2CO3. Look at this. Carbonic acid. It has 2 protons, so the ionization takes 2 steps. Remove 1 proton first, will become HCO3 negative. The other one will become CO3 negative 2. How about this? H3PO4. 3 protons. So the ionization takes 3 steps. For the first step, remove 1 of them. Will become H2PO4 negative. Remove the next one. HPO4 negative 2. The other one, this is 2, will become PO4 negative 3. Mister, 1 proton per any step must be removed. Very good. Now, let's write the ionization for the polyprotic acids. Try to write this title. Ionization for the polyprotic acids. Ionization for what? For the polyprotic acids. Let's see. Okay, I'm starting from H2SO4. How to ionize H2SO4? First of all, it's a diprotic acid. So ionization for this diprotic acid takes 2 steps. H2SO4 plus H2O. H2SO4, it's a strong acid. So the direction must be the direct arrow, I mean. Okay. Will become, remove 1 proton to the, and add it to the water molecule to become what? H3O plus, remove 1 proton, what left? HSO4 negative. Still, we have 1 more proton. Take this to here. SO4. Another one, good. HSO4 negative. Look at this. Because it has one more proton, so bring this to here. Now, still, it's inside of the aqueous solution, so it will react with another water molecule. From the second step on, always, for the second and third steps, use the reversible arrow. Use what? Reversible arrow. Even initially, even if the acid was a strong acid initially, but for the second and third step, always try to use the reversible arrow. أقدم هي خو تقلم معي باش. Reversible. Remove this proton to the water molecule also will become H3O plus what? SO4 negative 2. Is there any more proton here? No. Done. This is called the ionization of H to SO4. Because it's a diprotic acid, the ionization takes 2 steps. Another example. H2 CO3. H2 what? CO3. Again, plus H2O. Carbonic acid, it's a weak acid. So try to use the reversible arrow from the first. Remove one proton, add it to the water molecule. Water will become H3O plus what? HCO3 negative. Good. Now, still, there is one more proton. So bring this to here. Bring it to here, please. Because it's inside of the container still. So HCO3 negative plus by H2O again. This is reversible without thinking. Remove this one, add it to the water molecule, will become H3O plus by CO3. CO3 negative? No, mister. Add one more negative. Either by double negative like this, or you can write this negative 2. Good? Again, H2CO3, because it's a diprotic, so the ionization takes 3 steps. How about this one? I know, now you're looking for the triprotic acid. H3PO4 plus H2O. Good. Reversible arrow to form. Remove one proton, add it to the water molecule, PO, plus what left? 2 protons here, H2PO4 negative. And now, bring this to here again, because it has 2 more protons, plus H2O, reversible to form H3O, plus what? Remove one more proton here, will become HPO4 negative 2. Mister, there's one more proton. Please don't leave this don't leave it like this. Good. Bring this to here. HPO4 negative 2 plus by H2O. Remove this one, add it to the water molecule, will become H3O plus PO4 negative 3. That's how you write, or just like this. You can write the ionization for any acid if it's mono or di or triprotic. Now, let's learn something. Assume we have H2SO4. This is a very common question in Zhyar. Aqueous solution of H2SO4 contains how many particles? As I told you, this kind of question is very common. It is a very common guess for the Zhyar. Or aqueous solution of H3PO4 contains how many particles, or contains A, B, C, D. Then you'll read the choices, you'll know. Okay? Yalla. This is a shortcut scientific way. I'm not using the fast way. Look, fast way with a shortcut scientific way is, they are totally different from each other. يعني fast way بكارنا ما بدن بحياتي أصلا إيمان بطريقة fast way يعني يكشف بيقولوا من فast way جاني من ده مش شاكة بعد من طبعا modern chemistry, the great 12 of chemistry has been written by 4 of the greatest scientists. دوانیان ئەمریکینە، ئیندیانە چانەگەرە لەگە دانش کەنەدی. 4 زانانە بەتایبەتی ڕایمۆند هۆڵدمێرز ئەوانە زۆر بەناوبانگن. ئەو 4 عالمەیە ئەو کتابەیان نووسیە کە ئەو کتابەیان نووسێت جیا لەوەی لیزنە چیش کۆمیتیەک پێداچوونەوەیانەوە کردیە. سۆ دڵنیا بە ئەگەر تەریقەکی فاستوەی بە مێشتی بەڕێستاندا هاتبایە بە مێشتی وانیش دادەهات ئێستا لە کتابەکەی دەیان نووسی. ئەگەر ئەو تەریقەی باسی دەکەی کە دەڵێ ئەوە ئی خۆمە هەم پرسیارەش پێ حەل دەبی، ئەگەر هەموو پرسیارەش پێ حەل بایە ئەوان دەیان دەنا. بەس دڵنیات دەکەمەوە هەر تەریقەت کە پێی دەڵێی فاستوەی حتمما پرسیارەکەی تێکی یەشتێنی، حتمما ئەکسپشنە و لیمیتیشنە چی هەیە. لێ بە فاستوەی مەڕۆ کتاب. This is our main guidance. Okay, the shed light is the book. And دەتوانین بڕێن ئەو تەریقەیە علمیان شۆرکەتە چیلۆ دروست دەکەن، بەڵام فاستوەی نا. شۆرکەت یعنی کۆ مەسەڵەن علمیان دوو ستێپی بازە دەین دەچینە سەر ستێپەشکاوەوە. باشە بەڵام فاستوەی یعنی قانونێکی لە خۆڕە دابنێ و برێەوە شتی وان نییە. ئاشەبابی من. Okay, H2SO4. Which ion is produced by H3PO4? Hydronium or hydroxide? Hydronium, of course. H3O. Now, release the first proton will become HSO4. Release the other proton will become what? SO4 negative 2. Let's have the same thing this time for the carbonic acid. H2CO3. Okay. It will produce hydronium ion, which is H3O. Then release one proton. It will become HCO3 negative. Release the other proton. CO3 negative 2. Let's do the same thing for the phosphoric acid, this molecule. H3PO4. It will produce H3O. Then remove first proton. Will become H2PO4. Another proton will become HPO4 negative 2. Another proton PO4 negative 3. Get. Then OPO4, of course. Of course. Good. Now, look at this. Going from left to right. Ionization is decreased. Concentration is decreased. Basicity is increased. Okay? Basicity is what? Is increased. Okay, look at this. H2SO4, it's a strong acid. This is an exception, okay? If the acid is a strong acid, so, you know, the minimum concentration will be for the acid's molecule itself, and sometimes we will say it will become disappeared. But if I compare the concentration of this to the other concentration, it will be the minimum concentration. Good. Now, for the concentration, this one has the greatest concentration, then this, then this. Okay? So, your left side is the maximum concentration. Your right side is the minimum concentration. But for the H2SO4, this is different, as I said, okay? Your left side is the maximum concentration, and this one is the strongest base. Okay, strongest base. Strongest base. Mister, that means from left to right, the basicity is increased. Later you will know why. Mister, so if we have a polyprotic acid, example, H3PO4, remove all the protons, what left? PO4 negative 3 will be the strongest base compared to the other particles in the aqueous solution. Or in this aqueous solution, H2SO4AQ, tell me which one is the strongest base. Remove all the protons. SO4 negative 2 is the strongest base compared to the other. Okay, in this aqueous solution, H2S, AQ, which particle is the strongest base? Remove all the protons. S negative 2 will become the strongest base compared to the other particles in the aqueous solution. Good. Let's do the same thing for this. This is a weak acid. We have no problem with this. Again, just say, mister, this one, it has maximum concentration. Okay? And this is minimum concentration and strongest base. compared to the other particles. Okay, yalla, here, this is maximum concentration, minimum concentration, and this is a strongest base compared to these particles. Good? Just like this. I'll repeat this again. Only for H2SO4, will be different. For H2SO4, don't count H2SO4. Good? This is maximum concentration, and this one will be minimum or will become disappeared. But for the other acids, because this is the only strong polyprotic. Okay, for this one, maximum concentration, minimum concentration, and strongest base. For this one, maximum concentration, minimum concentration, and this is a strongest base. Just like this always. Yeah. So now, aqueous solution of sulfuric acid contains what? Okay, sulfuric acid is H2SO4. Okay, the first ion is H3O, then HSO4 negative, then SO4 negative 2. Because it's a strong acid, so it will become disappeared. How many particles do we have in the aqueous solution of sulfuric acid? H3O, HSO4, and SO4. So we have 3 particles. Good? Because the acid is strong, will become destroyed, will become disappeared. Good. For the phosphoric acid, okay. So aqueous solution of phosphoric acid, H3PO4, contains what? So let's write down all the particles. The first ion is H3O, then remove 1 proton, H2PO4 negative, another proton, HPO4 negative 2, another proton, PO4 negative 3. Mister, this is a weak acid. Yeah, we will get this. This one. So we have 1, 2, 3, 4, 5 particles. But remember, and always, there will be molecules of H2O because, you know, they have been dissolved in water and the solutions are aqueous. Be careful, my dear. Good. So I have explained the whole contents here. Very good. I have explained every single point here. Every. Look, aqueous solution of H3PO4 produces what? Okay. You know this. إستا أكيد ما قد ليرة أو explain كمو زين استكي لو شوي نيرك فيديو كي أون ده بيش طاقتني جرا كده وسكت باسم كده زور. It's time for the conjugates. Okay? It's time for the conjugates. Inshallah, next lesson I will explain the conjugates. What is the term of the conjugate? Conjugate acid or conjugate base? How to recognize them? And what is the relation between them? Okay? Taukat, Harshad bin.